So, hello everyone, and welcome to this introductory session of a new course that we are going to start. And the course is Design and Detailing of Steel Structures using the AISC codes. So, we will have a small 40 minutes presentation where I will just take you through what is going to be covered in the course and other details. And after my presentation is over, then we can have your queries, etc. So hello everyone once again, and thank you for joining us, those who are watching this live, and also welcome to those who are going to watch this session later. So let's quickly run through the agenda. So we'll start with why to learn steel design, then why did we think of starting a course based on AISC codes. I mean, why to learn steel design using AISC codes? Uh, what is the need for this course? A few things about us. Then we will go to the details of the course, what all things are going to be covered, the course contents, etc. And then we will take you through the intended course outcome. And in the end, we will have your queries. Okay. So, why to learn steel design? So, I mean, I need not emphasize this, but as you all know, that steel structures find a lot of usage and they are quite important in infrastructural and industrial projects. And not only this, in the Indian context, also these days, you will find that their usage has increased in the commercial and residential space also. So, wherever you have the issue with labor, where labor is expensive, people will try to go for steel because steel construction is not very labor intensive work, unlike RCC. So in wherever in the world, in whichever markets you see that labor is an issue, people will switch to steel construction instead of going with RCC. But despite their use or despite the importance of steel structures, I have quite often seen, and you might have also seen in the practicing field, that people find or structural engineers find difficulty in structural steel design. And I think the reason is it's not taught properly at undergraduate or postgraduate level, and the books and documents are also not covering the practical aspects of design, although there are many good books which cover the theoretical aspects quite well, but uh, they may not be able to cover the actual practical approach, and therefore the structural engineers are unable to sort of learn during their coursework. Also, many of the design firms are only doing or they are mostly involved in doing RCC projects. So the structural engineer is not able to learn steel design on the job also. So there are fewer companies uh, or fewer consultancy companies, fewer design companies which are involved in steel projects or steel design. Many companies you see, or more companies you see, are involved in the RCC design. And of course, one of the reasons is because RCC construction is more prevalent if I talk in the Indian context. But when you go to, let's say, West Asia or Gulf countries, Middle East, there you will find many companies do a lot of steel projects also because their heavy duty industrial work, or let's say oil and gas industry, deals a lot with steel structures. And therefore what the trend has become these days, that many structural engineers, because they are not confident enough in doing steel design themselves, so they often rely on pre-engineering companies or companies which do the design and execution work for them, thereby saving the effort of a practicing structural engineer. So the trend these days is that because steel sorry because structural engineers may not be capable enough or confident enough of doing steel design projects, they will give their work to a pre-engineered company who will do the design and execution, and thereby saving the efforts of structural engineer. Same is happening with the PT design also these days. So because structural engineers or civil engineers are unable to do the PT design on their own, many of the companies have taken over that task and they do the PT design and execution as well. Anyway, so therefore, I believe or I think that steel design becomes quite important for us as structural engineers to know and understand. And at AuxEn, we have conducted a lot of different courses which cover steel design and different aspects of steel design in a lot of detail. So this is another course which will cover steel design, but this time we are going to cover steel design using AISC codes. Now the question arises, why at all to learn steel design using AISC codes? Okay, in the audience, in the live audience, those who are attending, in your companies, are you using AISC codes for steel design? Those who are attending this session live may write in the comment that are they using AISC codes for steel design at their workplace. So many of the Indian companies also, MNC companies, they are using AISC codes for their steel design projects. And because many of them are doing projects outside India, therefore they are forced to use AISC codes. Okay, so many in the audience are saying that they are using AISC codes. A few of them are using IS codes. Very good. Anyway, so now the question arises, why to learn steel design using AISC codes? If let's say we are not required to use AISC codes for our projects, we are anyway in Indian market, so we are using IS codes. So why do I learn AISC codes? Okay. See, if you are working outside, then there is no question. You will be, let's say you are working in Middle East, Gulf countries. Mainly their codes are based on AISC codes, so there you are anyway bound to use. But let's say you are working in a geography where AISC codes are not used. Then why to learn steel design using AISC codes? So let's see. So AISC codes are, in my opinion, one of the most up-to-date design standards, design specification, which are updated quite regularly. So I think they have an updation cycle of 6 years, if I can recall, because 2010, 16, 22, yeah, 6 years. So every 6 years, the American AISC steel design codes, the codes that we are going to deal with mainly, they get updated. So they are quite up to date, and they incorporate a lot of the latest research work in their codes. So from time to time in their updation, the latest research is included. The research finds a place in the codal provisions. So they are most up to date standards. And if you see, they have become accepted specification for structural steel buildings across many countries in the world. Okay, so not only in the America, not only in the US, but also in other countries, they find a lot of acceptance. So there are several countries that do not directly use AISC codes. They may have their own country codes, but their country codes are based on AISC standards. Okay, so they might have a standard of their own. Many countries do this thing, that they will have a design standard of their own, but then they will refer to AISC. For example, the Saudi codes, Saudi Arabia codes, they have their own design standards, but then they refer to AISC or ACI. Okay. In Indian context, IS 800 is largely based on which country code? So the IS 800 is largely based on the British standard. Okay, IS 800 is largely based on the British standard. So the codal provisions, if you see, they resemble to the British standard. But then, if you look at the latest ductile design detailing code that has been launched by Indians BIS, IS 18168, that is completely based on the AISC 341. Okay, so it's a mixed approach. It's a mixed approach that the Bureau of Indian Standards follow. IS 800 is based on the British standard, uh, or Euro. Yeah, I mean earlier it was all British, then it became Euro, and now since the separation of UK from sorry, the separation of Britain from Euro, again I think they have come back to British standards. So the IS 800 historically has been based on the BS, British standards. Interestingly enough, the IS 18168, the ductile design detailing code for steel structures, is a total copy from AISC. So what I want to say is that even if your code is not, even though you may not be using AISC standards, but your code might be based on it. All right. And there is another trend that you see in the market these days, that many clients or many consultants do use AISC codes even for Indian projects, which may become slightly dangerous in some cases. Dangerous, by dangerous I mean that you take wind and seismic effects from Indian standards, you take the design formulae or the load combinations from the American standard, that mix and match approach will become dangerous. Okay. So that mix and match approach should not be followed. Let's say if for Indian project or if for some other country project you are using American code, then you do all the calculations, including the wind load, seismic load, load combinations, everything you do as per the American code. So don't mix and match codes. All right. Anyway, so in the Indian projects also, you will see increased usage of the American standards, mainly because it covers a few aspects that Indian codes do not cover. Okay. And same in the other country context also. Anyway, so several countries that do not directly use AISC codes have their country codes based on them. Now, the basic steel design code is the AISC 36022. 22 is the year of latest revision, and it's quite a comprehensive document. If you go through it, it's not very thick, but then there is a detailed commentary with it. So it's a comprehensive document which involves a lot of different design concepts, and there are a lot of different limit states which as a structural engineer you should properly understand. And uh, yeah, I mean you should properly understand. So even though you may not be using the code, but an understanding of this code, I think, will help you in your understanding also. In addition to this, so AISC 360 is the base code, just like we have IS 800. In addition to this, they have a specialized ductile design and detailing code also, that is called as the AISC 341. Okay, just like in the Indian context, now we have the IS 18168. So similarly, the Americans have the AISC 341. What is the Indian code for ductile design and detailing of RCC structures? Ductile design and detailing of RCC structures, which is the Indian code for it. So we all know it is the IS 13920. Okay. So similarly, for steel structure ductile design detailing, we have the IS 18168. And in the American context, for the ductile design and detailing of steel structures, they have the AISC 341. Okay. So yeah, so AISC 341 is that code. Another interesting code that they have in addition to AISC 341 is the AISC 358. So it is for the pre-qualified connections. Pre-qualified connections for special moment resisting frame systems and for intermediate moment resisting frame systems. So suppose you are going ahead with ductile design and detailing, and the system that you have adopted is, let's say, special moment resisting frame, then the connections, beam column connections, for that there is a specific code called as AISC 358, which is the pre-qualified connection. Sorry, the code for pre-qualified connections. Pre-qualified connections is an interesting concept, which says that suppose you follow the step-by-step procedure given in this code AISC 358. So it's an algorithmic process that is given. So suppose you follow the step-by-step design process, detailing process, configurations, if you follow as per the procedure laid out in AIC 358, then the connection will behave as per accepted standards under a seismic event. Okay, so you can be assured of the connection behavior if your connection is designed in accordance with this step-by-step procedure given in AISC 358. So therefore the term pre-qualified. Okay, uh, so the connections for SMRF and IMRF systems can be based on this AIC 358, and then you can be assured of their expected performance under seismic action. So this is an interesting code. We don't have such code in the Indian context right now, or I think any other country code uh, also don't have such kind of a pre-qualified connection code which the Americans have. So for ductile design and detailing, these two codes become important. So as structural engineers, not only we should understand the AISC 360, but we should also be able to use the 341 and 358. And then after, it's also important for us as structural engineers to not only theoretically understand all these things, but also be able to execute these things on software like ETABS or STAAD. Okay, so ETABS or STAAD, because they are American in origin, they support the American codes quite well. Okay, often we find this issue with other country codes, that the software has some or the other limitation when it comes to uh, application of those codes in these software. But I think because all these software are American origin, they are able to incorporate all the provisions of these American codes quite well. Okay, so therefore, as structural engineers, we should also be able to use these software and understand what they are doing for steel member design and also for connection design. Okay, so yeah, so ETABS and STAAD, let's say for steel member design, and a software like Idea Statica for connection design, as structural engineers, we should be able to understand their usage based on the AISC codes. So these are the things I think as a structural engineer are important for us, and as a structural engineer, we should try and learn steel design using the AISC codes. Now, how this course is going to address this issue or these issues? So, through this course, we will provide a platform to have an in-depth understanding of not only the member design but also the connection design based on AISC 360, and the ductile design and detailing based on AISC 341 and AISC 358. So, this is what we are going to achieve through this course. Also, this course will help the participants to first of all understand the calculations, the design calculations that are being performed in softwares like ETABS and STAAD for member design, and how all the connection design is happening in Idea Statica, of course, based on AIC code. So because there are a lot of limit states in the American code, see, people find the IS 800 quite complicated. But if you read the AISC, it has far more number of limit states than those given in IS 800. So IS 800 will feel simpler if you compare it with the AISC. Of course, it's not difficult AISC, but just that if you understand the basics well, then uh, everything will be demystified. but otherwise you will be lost in a sea of formula if you look at the AISC 360. But then if you are able to understand and make sense of it, then I don't think it's very difficult. Yeah, so through this course, we will help the participants, or this course will help the participants to use these softwares like ETABS or STAAD for member design, and uh, Idea Statica for connection design. And we will also take two low rise steel building projects through this course in the duration of this course, which will help the participants to apply the concepts that we have learned for an actual project. I'll explain why we are taking two sample projects instead of one. And these are a few things about our consultancy firm KCEPL and our training firm AuxEn. I think many of you know all these things, or you can read it out. So I'm just going ahead with this. So we are, as a consultancy company, we do a lot of steel, RCC, composite, this, that, industrial, commercial, residential, infrastructural, lot of different projects we do. I'm just going to skip through this. You can watch these things later online if you wish to do so. So these are some images when we used to conduct offline sessions. Then these are some sessions that we have conducted, some technical lectures, and these are the list. This is the list of the courses that we have conducted, online courses that we have conducted since 2020. So we have been overwhelmed by the response that our participants have given us, and participants have been from all across India, and also the other countries in the Indian subcontinent, the Middle Eastern countries, the West African countries, South African countries, and a lot of other participants we have had from different geographies. And we always have participants which are mix of graduate, postgraduate students, research scholars, practicing professionals, consultants, faculty members. So it's always a great mix of participants we have. So anyway, you can watch this. And so over the years, what we have been doing, so we try to focus on two aspects. So as a structural engineer, you should have a strong theoretical base with ability to use the software as per your need, and then you should also have experience of doing actual projects. Both are important. One without the other is not effective enough. Okay, so both are important. So to address these two aspects, what we have done, we conduct short term courses. They also are quite long, they are not short, but we call them short term. So these short term courses emphasize more on the theoretical understanding and software proficiency. And then we have some project design courses where we conduct these project design courses mainly focusing on doing actual projects. So as structural engineers, because we think that both these aspects are important, that is having a strong theoretical base with software proficiency plus experience of doing actual projects. So to address these aspects, we conduct or we have a two pronged strategy. Okay, so yeah, so till now online we have conducted 21 online courses, 12 of which are available to be taken as self-paced learning courses, and we have also conducted three project design courses. And in addition to this, we have conducted two 6 months structural design center programs also. Anyway, so let's move ahead. And our impact, we gauge the impact that we are having for our participants through taking the impact assessment surveys. So we have been able to make a positive impact for the participants, not only in the conceptual understanding but also when it comes to software proficiency, or when it comes to understanding of the design codes, or when it comes to the work performance of participants in their work, or even in their job search. So we have been able to make a positive impact in all these aspects for our participants, and we are very happy about that. Okay, so I think this is me, you know, and on left is Akanksha. She is my wife, and we both are structural engineers, having done our graduation and then post graduation. Okay, so let's now come to the course contents. Important, which what all things are going to be covered, and how are we going to proceed in this course. So I'll start with the brief discussion on different structural steel systems and their load path. I mean, all of you know it, but then we will discuss it during the course. Then we will go to the introduction of AISC steel codes and their historical development. Here, I would like to just tell you that just go through this website, AISC.org, I think. Okay, that is the official website of AISC. It's quite informative, and you will find a lot of tools and lot of different resources over there. In fact, they have a long list of Excel sheets also, that which have been uploaded by different engineers just like us, and those Excel sheets or other resources are freely downloadable. So you can have a look at those documents, those resources. Go to their website, aisc.org. It's quite informative, and you will love to just spend your time on that website. So highly recommended. Okay. Then there are some design guides also that are there on the website. Maybe those are paid design guides, but then you can obviously find the free copy of those design guides also on the internet. So you can look for uh, downloading those design guides. I think there are some 40 design guides that AISC has published till date. So try to find those design guides online. I think you will get a free PDF copy somewhere on the internet. So download them, and it's a good resource to understand and go through steel structures and various aspects of design, steel structural design, that is. So yeah, so we will have just so we'll understand or the historical development of the AISC steel code. When I say AISC steel code, I am going to mainly focus on the parent. Let's call it as the main AISC 360. There are different AISC codes, but of course, because our work uh, is on understanding the main structural steel code, we will. When I say AISC code, I mean AISC 360. Okay. Then we'll go to understanding the important limit states in steel design. For example, the let's call it as the yielding limit state, or when it comes to tension yielding, or the tension rupture, or when it comes to compression, the flexural buckling or the torsional buckling, or when it comes to flexure bending, the limit states will be, let's say, yielding or compression flange buckling, or the lateral torsional buckling. So all these limit states are important for us to understand, because the design of members is based on or is governed by these limit states. So we'll understand the important limit states in steel design, and then we will understand these two methods that are highlighted in the AIC 360 code, that is the load and resistance factor design and the allowable strength design, LRFD and ASD. Okay, nothing very difficult in this, but we'll understand these two different design methods that have been outlined in the code. Then we will have a discussion on the different material grades, because you will often it becomes quite confusing, because there are a long list of different material grades, ASTM grades given in the codes, so it becomes difficult for us to understand. So then we will have a discussion on material grades, and then we will have discussion on the different sections, section sizes, different sections available, and the section classification, very important, because the different limit states are governed by the section classification, or I should say the section classification is done as per the different limit states. So this becomes important for us to understand. And here the approach that the American code adopts is slightly different from the approach that the Euro or the British or the Indian standards adopt. So it will be interesting for us to go through the this. Then we will uh, do the load calculation. So these two things, although I have written it over here, but these two things we will do when we take up a sample project also. Okay. So when we take up a sample project, we will do the gravity load calculation, because then we are doing the sample project, we have to apply load. So for the sample project, we will have to calculate the loads. So gravity load calculation and wind load and seismic load calculation, we will do it as per the AISC 7, which is the code for all sorts of loads to be applied on the structure. So for the sample project, we will do these calculations. Yeah. So after this material grade, so this is a small change in the sequence that I have made. So after discussion on material grades, this, then we will go to the different types of analysis requirements. So in the American context, there is a direct analysis method, and there is an effective length method, and there are two three other analysis methods that are given. And in the direct analysis method, there is the p delta effect that you have to take into account. There is the concept of notional loads that you have to take into account. So all these things we have to consider in the direct analysis. And then there is an effective length method. So all these different analysis methods we will discuss. It is important for us to understand, because these aspects are usually ignored or not so well covered in the, let's say, in the Indian standards. These aspects are not very well covered, and the American code emphasizes a lot on this. Okay. And because your software also help you with it. So as I told you, software like ETABS and STAAD are American origin, so they incorporate the American codes quite well. Okay. So we will go through these analysis requirements and try to understand the different analysis methods given in the AISC. Then once the analysis techniques and once the interpretation of analysis results is done, then we will understand the design of member for different design actions. So how to design the member for tension, how to find the capacity, how to find the utilization ratio for member in tension, what is the what are the formula given in the American code. We will do it. All these calculations we will also do manually and verify it with the software outputs. So for tension, for compression, for flexure, for shear, torsion, and for combined actions. So all these find different chapters in the American code. For example, chapter D covers tension, chapter E covers compression, chapter F I think covers flexure, combined actions is given in chapter H, and so on. So different chapters are given in the American code for the design of these members for different design actions. So for this, we will do the calculations manually for different conditions, verify it on Excel sheets that we have prepared, also verify it with the software output. Okay, so this will be a very interesting part of our discussion. Then once we are done with the member design, then we will go to the connection design. Connection design, I think, is covered in chapter J of AISC 360. So we'll begin with the basic requirements for welded and bolted connections. Then we will discuss the proportioning and design for welded bolted connections. and then we will go through some important connections, which are, let's say, beam to column shear connection, beam to column moment connection, beam to beam connection, uh, beam to beam and column to column splice connection, column base plate connection. So all these connections we will cover. For this, we will use a mixed approach. That is, we will do manual calculations where we can, plus we will do it on Idea Statica, which will be a software for connection design that we will use. So this is how we are going to do, and for this we will do the manual calculations. When I say manual, we will do it manually, live, uh, and also we will take help of some Excel sheets to ease out our work. Okay, so here we will do manual and ETABS and STAAD, all those things we will use. All right, very good. Then, so once this is done, once the basic steel design is covered, then we will go to the ductile design and detailing. So again, when we go to ductile design and detailing, then there are specific requirements for member, there are specific requirements for connection. So all these things we will understand. Now this discussion will be based on AISC 341. Then we will go to the system requirements and the design and detailing procedure for different lateral load resisting systems. Mainly, we will focus on the IMRF and SMRF. This is the main focus. This will be our main focus. But then we will also discuss the other two lateral load resisting systems. That is the concentrically braced frame and eccentrically braced frame. In the American AISC 341, there are several other systems also given, but we will not discuss those. Mainly, our focus will be on the moment resisting frames and the braced frames. Okay, but there are other systems also that are given in the AISC 341. Anyway, then once this is done, then the connection design, it's quite important as per the ductile design and detailing requirements. So then we will go to connection design, and in the connection design itself we will go to the pre-qualified connections, as I was explaining you, using the AISC 358, which is a code for pre-qualified connections for special moment resisting frames and intermediate moment resisting frames. So this we will do. Yeah. Then, yeah, so then we will sort of towards the end, we will take up two sample projects. Now, why we are taking two sample projects? Because one of them we will take it in such a manner that it is governed by wind loads, where the seismic ductile design detailing requirements may not be applicable. So let's say if your structure is in seismic design category A, so in the American ASC you don't have zones, you have the seismic design category that you have to find out. Okay, so let's say your structure is in seismic design category A, then the ductile design detailing requirements will not be applicable. So then in that case the lateral load governing will be wind load, let's say. So we'll deliberately take a project where ductile requirements are not to be satisfied, so those, that design will be governed by wind load. And then we will take another project which is governed by seismic load, where we will have to apply the ductile design detailing requirements as well. So in this manner I think we will be able to comprehensively cover both a non-ductile and a ductile structure. Okay, very good. Special focus will try to give on three plate sections. Three plate section means this type of a section where you have two flanges and one web. Why are we giving focus on these types of sections? Because they find extensive use in steel construction. Also, with the increasing popularity of pre-engineered construction, most of the pre-engineered companies, because of the uh, better welding techniques now available. Most of the pre-engineered building construction companies prefer to use these kinds of three plate section or built up sections. Okay, so our focus also will try to focus more on usage of these types of sections, and then also on the hollow sections, because hollow sections also quite find a lot of usage in steel construction, and because hollow sections have some inherent difficulty also in connection. So I think for us as structural engineers it is important to understand these things. So special focus will be given on three plate section and hollow sections. Good. And then the standards and design codes which we will refer to, just a minute. Design standards and codes which we will refer to will be, of course, the AISC 36. Oh, this is AISC, okay. AISC. AISC 360, AISC 341, Ductile Design Detailing Code, AISC 358, Pre-Qualified Connections, AISC 7, which is the code for loading. And in the course, which are the software we are going to use? So we'll be using ETABS and STAAD for member design, Idea Statica for connection design, and MS Excel because we are going to make some Excel spreadsheets and use it. So these are the course contents, and these are the things we are going to include in our course. And the live sessions for these course, as we usually do, are going to be conducted at 8:30 a.m. Indian Standard Time during the weekdays. Now, what about, because majority of our participants are not able to attend the live sessions. I think only 5 to 10% of our total participants, not even 10, 5-6% of our participants attend the sessions live. Most of the participants take our courses as self-paced learning courses, which means that after every session that we conduct, we record it and then we upload it on our learning platform where our participants can log in and watch those sessions as per their convenience. So, as I told you, almost 90 to 95% of all our participants prefer this way of learning, because then they are able to watch the sessions as per their convenience, and then they are not bound with time, not bound with, yeah, not bound with time. They can watch as per their convenience, and this course will have a validity of 12 months. So during the duration of 1 year, you can watch these sessions whenever and wherever you find time, whenever it is convenient for you. And of course, from time to time in the course, we will be taking examples of relevant cases. And as I just told you, two actual projects, sample projects we will take up. And so, who will benefit from this course? So, all the fresh graduates or postgraduates in civil structural engineering, or if you are a structural engineer who is looking to start up as a consultant, or who is looking to join a job and wants to upgrade his or her knowledge on these design standards, or let's say you are working somewhere already and you want to skill up, and it is a requirement in your company that AISC codes have to be learned, or let's say you are an experienced structural engineer but just looking to deep dive, or anyone in general who loves structural engineering and wants to learn more, all of you are welcome to join this course, and I'm sure you will benefit from this course. So, what is the intended course outcome? So, at the start of every course, we list down the outcome, and then when we conduct the concluding session, we try and see if the outcome was met. So, what is the outcome course? What is the desired outcome? So, the participant after this course will have an in-depth understanding of structural steel design, as per the AISC codes. The participant will be able to use the software for the project work, uh, to carry out the design and detailing for actual steel structures, and the participant will then be able to apply all these learnings for an actual project using ETABS, STAAD, Idea Statica, etc. So this is the desired outcome, and I can assure you that we will meet this desired outcome when we finish this course. So now, after this session, if you want to join, you can join by paying a course fee of uh, 9,750 rupees, and if you are an international participant, 150 US dollars, and the payment details and the method to carry out this payment we will share with you separately. And then, so once you do your payment, we will add you to another WhatsApp group, which will be the WhatsApp group for our course, where the daily link details and other updates will be shared. And then our live sessions for this course will start from 24th of February, that is next Monday. We will start with the live sessions for this course. So before we take up queries, some queries that you may have in your mind, let me try to answer. So first query that you may have is that you are not from India. How can I join the course? So as I told you, if it is difficult for you to join the course by watching live sessions, you can join the course as self-paced learning course. And for international participants, the payment details will be shared to enable you to do international payments. Second question that you may have in your mind, that you are a working professional or practicing consultant or faculty member, you're not getting time to attend the sessions live. So how can I join the course? So as I have already addressed this issue, so if you are not able to watch the sessions live, you can join the course as self-paced learning course, where you can watch the sessions as per your convenience on our learning platform. Okay. Another question you may have in your mind is, uh, that you are new to steel design, should you join? So yeah, because in this course we are going to cover the steel design based on AISC codes from very basics. In my opinion, you can join this course even if you are new to steel design. So that's all what I have to cover in this introductory session. And now, if you have any queries, we are open to your queries. Yes, please. Any questions, queries, doubts that you have related to this course or related to what we are going to cover in this course, please. Yes, any questions, queries, doubts, difficulties related to this introductory session? So Azai is saying, please reduce the fees as we students can pay. Unfortunately, this will be the fees that there will be, uh, and yeah, I mean, I am unable to add any further comments for this. The fees will remain the same. Mr. Ankit Jain is asking if in a session we have any doubts. So as I told you, or I did not tell you. So for each course, we have a different WhatsApp group where you will be added. So let's say if you are joining the sessions as self-paced learning, then, and if you have any doubts, you can solve your doubts or ask your doubts on our WhatsApp group. or on personal message call, or we also conduct periodic discussion sessions. Every weekend we are conducting sessions where you can clear your queries. So all these different approach you can adopt to clear your queries. Okay. Engineer Bharat Bansal is asking, will the design cover angles and channels? Yeah, see, we will take up angles and channels also, but then I will not emphasize, or I will not be elaborating a lot on manual calculations for angles, channels, other sections. Of course, software are able to do it, and there are formula given in the AISC 360. Uh, and there are formula given in AISC 360 for angle shapes, for channel shapes, etc., etc. But we are not going to emphasize a lot on it. That's what I meant. Okay. Why we are not going to emphasize a lot on it? Because they find reduced usage in steel structures. Of course, angles are used for bracings. Channels are used for lightly loaded beams or for columns also. So we will use angles, channels, but then we will not elaborate it. We will not go into manual calculations for angles, channels, etc. So my focus will be more on the hollow sections, plate sections, built-up sections, which are used extensively. Okay. Yes, good question by Engineer Anshul Gupta. Metric or FPS? Yeah, I slipped, I missed addressing this issue. So American codes are based on, I mean, the Americans do their work based on FPS, maybe as a way to show that they are different from others. Technically, I don't quite understand why they use the foot pound system. Uh, I mean, it's not scientific enough to use the FPS. But anyway, they use the FPS system, but we will be using the metric system. We will not be using the FPS. Now, one advantage or one good thing about the AISC formula is, let me just tell you. So, suppose, let's say you have some output Y. Okay. So, this Y is equal to C into C is, let's say, some constant, C into x2 upon x1. Okay. Now, this is a formula. I'm just trying to explain you one thing. Now, let's say this is a formula given in AISC 360. All right. Now, the good part about all these formulae is that all these formulae have been made in such a way that if you put the consistent units, you will get the output in the same system. What I mean is that, let's say x2 and x1, let's say you put it as per the FPS system. Understand? So you will get the output also in what? You will get the output also in the FPS system. You get my point? Suppose you put the inputs over here in the metric units. All the formulae are arranged in such a way that their units get cancelled quite well. And if you put the inputs in metric units, you will get the output also in metric units. So the constants need not be changed. Sometimes what happens in the formulae that are dimensionally not consistent, that your constants change. So for, let's say, for FPS, a different constant has to be used. For metric, a different constant has to be used. That happens in dimensionally inconsistent formulae. Do you remember this? In first year engineering, we used to read about dimensionally consistent and inconsistent formula. I don't know if you remember this, but in the dimensionally inconsistent formula, these things happen. Okay, but in the AISC 360 formula, because all these formulae are dimensionally consistent, when you put your inputs in one unit, automatically you will get the output also in the same consistent units. So that is, I think, a good thing about the AISC 360 formula. So although we will be learning all these things in the metric, kilonewton meter unit system, but the same formula and the same, let's say, Excel sheet also, if you put the consistent FPS units, you will automatically get the output in the FPS system. Anyway, so short answer, we will be using the metric system because that is what many people adopt. So in the Middle East countries also, they might be using the AISC standards, but then they use the metric unit system. Okay, good. Thank you, Mr. Syed Fawaz Ali, for your appreciation. Mr. Anshul Gupta is saying there they use T sections more for bracing these days. Yeah, so for bracings, you might be using angles. For heavier bracings, you might be using built-up channels. Yeah, I do agree. But then we will not be elaborating the design of them. By elaborating the design, I mean we will not be doing a lot of manual calculations for it. We will rely on the software for their output. Mr. Shailesh Gupta is asking, is it possible to start sessions from 8 to 10? No, I think 8:30 is good. 8:30 to 10:15 we will do it. Mr. Sayyid Fawaz Ali is saying, I have sent an image of ETABS design result on your WhatsApp. I just need to know that let me see my WhatsApp, what he has sent. WhatsApp. Oh, yes, yes, we will be doing this. But this is as per Indian code, I think. This output that you are showing is as per the Indian code, isn't it? This ETABS output that you have sent is as per the Indian code. It is not as per the American code. So yeah, anyway, we will be doing the step-by-step understanding of the output also, that what output, detailed output ETABS is giving, will be understanding uh, each and every each and every value that ETABS is showing us, from where we are getting those values. All those things will be covered. Mr. Shailesh Gupta is asking, will structural steel drawing understanding? See, everything, I would say we will have a brief discussion on the structural drawings, but not in a lot of detail, because then it requires a very comprehensive discussion, which we may not be able to do, but we will have a brief understanding about it. Okay. Yes. Anything else? So, in fact, in this American standard design, the STAAD output that STAAD shows is better than what ETABS gives in the output. Okay, so interestingly, the design output that ETABS gives for the American standard, what I'm saying, the output, the detailed output for AISC that STAAD gives is better than what ETABS gives from an understanding perspective. So if you want to understand what a particular software is doing, the output STAAD is giving you is better than what ETABS gives you in the American context. Uh, if you look at the Indian codes, what ETABS gives you is better than what STAAD gives you in the Indian standards. Okay, so what I'm saying is the output for IS, ETABS gives you better output, is better than STAAD. But interestingly, for AISC codes, the STAAD output is better than ETABS. I'm just talking about the output. I'm not talking about the software in general. Okay, I'm just talking about the member output that the software is giving you. Yes, that's quite important. I do agree that understanding the output in detail, in depth, is very important for us as structural engineers, because if we don't understand how the design is happening, how the outputs are getting generated, it becomes difficult for us to take informed decisions. So I do agree that it is very important for us to understand. And thanks, Mr. Sayyed Fawaz Ali, for your appreciation. Mr. Bharat Bansal is asking, need better understanding of design parameters in STAT. Of course, we'll cover that. We'll do that, yes. All the design parameters, whether they are in ETABS or STAD, we will cover them in depth. Don't worry. We'll also see what happens when we change those parameters, how do they affect the design. All those things we will discuss. Okay. Yes. Anything else? Any other query that you may have? Okay. So I think then that's it. We hope to see you all in our course. That is the design and detailing of steel structures using AISC codes. And I think it will be one of its kind course, uh, which you will not find anywhere else. I can assure you that. So we hope to see all of you in our new course, which we begin next week. So that's all for today. Thank you for joining this. Mr. Gaurang is asking every day same time or fix another one time. No, every day same time. No different timings on different days, same time. Yes, Mr. Bharat is asking. Yeah, so once, yeah, we will take your email ID and then we will add you on our portal, and then you will be able to watch those sessions from next week onwards. Because next week we will have our first session, right? So next week onwards, you will be able to watch those sessions. Anything else? Okay, so the payment details and other things will be sharing with you. And we hope to see all of you when we start with this course next week. That's all for today. Thank you for taking out time and joining us. Bye bye. Have a good day.